3I Atlas, this new interstellar object, and that could potentially tell us how big it is, because the amount of sunlight that is reflected.
ES had just pushed raw frames from Cassie's on the ExoMars Trace gas orbiter, and tucked inside that dump is what everyone hoped for, and nobody was ready to see. A faint trackable hit on 3I/A/TLAS from Martian orbit. Within minutes, a claim detonated across pro forums and discords. The interstellar object went dark for 3 hours, then came back moving almost twice as fast. No precursor flare, no telemetry ramp, just a flatline in photometry followed by a kinematic jump that shreds the rulebook. If that's real, it's not a curiosity. It's a jailbreak from physics as we practice it. Context first. 3I/ATLAS is the third confirmed interstellar visitor in human history. Bigger by orders of magnitude than Oumuamua, brighter and more violently active than 2I/Borisov, and currently tearing sunward at approximately 61 kilometers per second, approximately 137,000 miles per hour. Size estimates cluster around greater than or equal to 5 kilometers for the nucleus. Think mountain, not boulder. The forum's headline is simple and horrifying. A 5-kilometer mass allegedly paused. Visible activity dropped to background for approximately 10,800 seconds. Then its reconstructed outbound fit implied a velocity step, like someone hit resume and punched the throttle. You want to know if that's possible? Short answer, no. Not with anything we've flown, not with any reaction mass we can lift, and not without leaving a thermal and spectral crime scene you could see from Pluto. To null a 5-kilometer body at 61,000 meters per second and then relight it at greater than 120,000 meters per second demands sustained impulse on a scale we associate with nuclear events, not thrusters. The momentum budget alone is obscene. The waste heat should scream in mid-IR, the dust geometry should torque and kink, the spin state should hiccup. These are not subtle effects, which is why, if this story survives the weekend, the light will rat it out. Everything in space leaves fingerprints. Brightness curves stutter when jets change. Colors tilt when grain populations shift. Heat maps spike when energy is dumped. Spectra blossom with short-lived lines when fresh volatiles are exposed. We have the right watchers in place. Hubble for precise color/phase curves. JWST for mid-IR thermal and molecular bands. High-cadence ground spectrographs for CO, CO2, H2O, CN, and now Mars-side parallax from CASSIS that can triangulate position, drift independent of Earth's glare. If there was a genuine pause plus surge, those channels should light up in chorus. Here's the sobriety check the pros are doing right now. Photometry. Did the light curve actually go flat, or did signal-to-noise crater during a geometry phase change? A dust jet rotating out of view can mimic a pause. A transient orientation that points the active face away from both Earth and Mars can fake invisibility without any drama at the nucleus. Astrometry. Are we comparing apples? Mix Earth-based and Mars-based solutions without proper clock/plate/PSF cross-cal. And you manufacture step errors that look like kinematic jumps. The first rule of impossible accelerations is calibrate again. Thermal. JWST's MIRI bands should show a cooling or heating transient if anything injected energy. No spike, no maneuver, at least not one that couples to the surface. Still with me? Good, because the weirdest clue isn't motion, it's metal. Multiple teams have flagged nickel in the coma, a lot of nickel. In most comets, Ni and Fe rise together. They sublime from mixed grains forged in ancient stellar furnaces and liberated when sunlight cooks the surface. Atlas is different. Nickel lines are strong, while iron is faint or absent in comparable bands. That's not impossible, but it is diagnostic. Nickel-rich, iron-poor vapor points to exotic thermal histories. Think hot processing in chaotic systems, tight binaries migrating hot Jupiters, violent collisions that metal-sort grains, or repeated peripasses that selectively liberate specific complexes. Ni carbonyl pathways, while Fe remains bound. Whatever system birthed this thing did work on its solids. Why should you care about a metal ratio while everyone screams about a pause button? Because composition controls behavior. Heavier, nickel-loaded grains change jet momentum transfer. They alter how torque builds as vents open, how the coma polarizes light, and how quickly the nucleus spins up or down. A body with carbon dioxide-dominated outgassing, already reported at extreme ratios, and metal-dense dust can produce non-intuitive, punctuated pushes without invoking engines. Crack a new vent into CO or CO2-rich strata, and you get a rocket pulse. Brief, directional, photometrically nasty. Do that while the active phase is edge-on from both Earth and Mars, and you've just faked a pause that's really geometry plus anisotropic venting. Now, could something artificial produce a dark window plus velocity step? If you were writing a checklist, you'd expect stepwise spin change, light curve period shift, not explainable by steady sublimation. Torques, narrow band flashes or non-thermal lines inconsistent with comet chemistry. Mid-IR excess decoupled from solar heating curve, power dumped fast, then radiated. Coherent parallax consistent displacement across Earth/Mars, baselines that can't be fit by standard non-gravitational models, A1/A2/A3 jets. That's exactly what HST/J, WST/ground arrays/Mars orbiters are hunting now. Not vibes, fingerprints. Meanwhile, the origin story hiding in plain sight is getting spicier. Rewinding the trajectory with Gaia star motions points into neighborhoods where gravitational pinball is routine, young clusters cluttered with giant planets, or compact binaries where orbits yank small bodies into ejection lanes. Those places cook dust hotter and fling comets faster than placid outer disk nurseries. A nickel forward signature fits that narrative. So does the speed. So does the CO2 heavy coma, which screams, built in a deep freeze zone, and then processed near heat. Bottom line, here's how to stay sane while the forums melt. Assume calibration first. 3 hours of silence during a tricky geometry, plus cross-platform reduction, is a trap we've seen before. Follow the 4 tells. Light, heat, gas, spin. If a real impulse happened, at least 2 will blip together. Watch the metal. The knee anomaly isn't clickbait, it's provenance. It tells you why the jets act weird and where this thing was forged. If the signatures line up for a true maneuver, we're in new territory. Propulsion without exhaust as we know it, momentum games we can't yet play, and a to-do list that starts with rapid intercept. If they don't, we still win. We'll have mapped in exquisite detail how a nickel-tuned, CO2-driven interstellar comet fakes a throttle using nothing but sunlight and fractures. Either way, the data decides. The pause event sent every observatory sprinting into triage mode. Within hours, NASA, ESA, and JAXA convened what insiders call a shadow sync, an off-calendar coordination call between mission leads, data pipeline engineers, and exoplanet photometry teams now retasked for comet work. Because when something that large allegedly stops, you don't debate on Twitter, you pull the raw telemetry. Hubble uploaded continuous UVIS frames across the gap window. JWST cued emergency MIRI thermal scans. The Atacama Large Millimeter Array tuned into CO and CN emission lines, sniffing for outgassing bursts that could fake acceleration. And ESA's Cassie's camera onboard ExoMars became the accidental hero, catching Atlas's silhouette from an angle Earth couldn't. Cross-referencing those data streams became the litmus test. If every eye saw the same pause, it's real. If only one did, it's a calibration ghost. What the teams found was stranger than either option. During that 3-hour window, Atlas didn't just dim, it flattened. The coma's brightness curve dropped to baseline, then stayed eerily constant. No flicker, no spin modulation. It wasn't flickering like a rotation, it was gone. Even thermal flux in JWST's mid-infrared bands plateaued. No sign of heat change, no cooling slope, no heating spike. That's what rattled people most. A perfect plateau across every wavelength, as though someone turned off the lights and kept them off just long enough for every instrument to agree. Then, precisely 3 hours and 14 minutes later, the curve reignited. Not slowly, instantly. brightness jumped 80%. Velocity reconstruction from parallax baselines implied a speed near 122 kilometers per second, almost double the inbound track. Within error bars, it wasn't a drift, it was a jump. That's the moment headlines screamed, "Pause and surge." But inside the data rooms, it got worse. A comet's dust tail acts like a cosmic seismograph. Even when the nucleus hides, the tail tells the truth. Solar radiation pressure bends it, and sudden accelerations leave ripples, shock patterns, kinks, or oscillations that betray thrust-like motion. When analysts ran light polarization reconstructions on Atlas's tail during the blackout, something showed up that shouldn't. A standing wave, fixed spacing, repeating every 38 seconds, the same rhythmic pulse seen months earlier when Atlas split into fragments. Except this time, the wave pattern persisted even while the comet itself vanished from optical view. Whatever went dark, the plasma around it kept humming. It's as if the engine room lights went out, but the machinery kept vibrating in perfect rhythm. Now, about that nickel. Post-pause spectra showed something new. Neutral nickel lines intensified by nearly 40%. That means material from deeper, hotter strata suddenly reached the coma. Fresh metal dust heated and ejected violently. The shift wasn't random, it corresponded to the re-illumination event, the same minute the light came back on. So, while the visible output died, the nucleus might have been cracking open, exposing metal-rich veins that erupted once sunlight returned. Dr. Ingrid Holm from the Swedish Institute of Space Physics called it a delayed exhale. The theory? Internal pressure built up under a sealed crust, CO2, gas trapped beneath dense, nickel-heavy layers. When that crust ruptured, the gas vented explosively, imparting a brief but massive push, enough to tweak velocity in a way that mimics acceleration. Not alien engines, just physics turned up to 11. Still, not everyone buys it, because the math doesn't add up cleanly. Even with optimistic assumptions about outgassing thrust, you'd still need 10 million times the vent strength of typical cometary jets to generate a sustained doubling of speed. So, either the event didn't happen as reported, or there's a new kind of venting process we've never modeled before. A rival camp thinks it wasn't thrust. It was capture. When 3I/ATLAS vanished, it was crossing a high-density region of the solar wind near a magnetic sector boundary. Some plasma physicists propose the comet's CO2-rich coma acted as a temporary magnetic sail. By aligning its charged particles against a solar wind reversal, the body could, in theory, experience a brief stall, followed by a slingshot-like acceleration when polarity flipped. It's speculative, but the timing fits. 3 hours is roughly the duration of the sector oscillation that day. If that's true, ATLAS didn't break physics, it used it. Still, that doesn't explain the rhythmic 38-second pulse or the precision of the blackout window. Which leads to the uncomfortable middle ground scientists rarely admit publicly. We don't know. Either nature just played the best magic trick in heliophysics, or something out there behaves by rules we haven't written yet. In the wake of the event, every major asset turned toward ATLAS again. Hubble launched into rapid fire mode, tracking micro-variations every 60 seconds. JWST locked MIRI and NIRSPEC on repeating cadence scans. Ground observatories from Chile to Hawaii shifted from asteroid targets to comet monitoring. Even Juno, orbiting Jupiter, was ordered to prepare long baseline readings for March 2026. Meanwhile, Mars orbiters remain the wild card. With different geometry, they can capture side-on jets Earth can't. If those frames show directed outgassing during the pause, it's over. The mystery collapses into physics again. But if the coma truly went dark across all bands, if nickel lines spike without heat curves, if the 38-second pulse keeps time like a heartbeat, then something unprecedented is happening inside the solar system right now. Let's run the math out loud. To stop a 5-kilometer rock moving 61 kilometers per second, even briefly, takes a negative impulse equivalent to the entire global power output of Earth sustained for days. To re-accelerate it afterward doubles that. No natural venting mechanism comes close. And yet, every astrophysicist from Caltech to Kyoto will tell you Extraordinary claims need extraordinary data, not extraordinary tweets. So, while social media screams engine, the labs whisper unknown physics. The truth probably lives between, a natural object doing something natural, but in a way we've never caught on film. And if it's real, we're about to learn more about interstellar chemistry, solar-wind coupling, and plasma dynamics than any mission in history. Comment below. What's your bet? Did 3I/ATLAS truly stop and jump? Or did we just watch the universe pull off a misdirection act with our own instruments? Stay tuned, because the next round of Mars data could settle it, or make it stranger. 3 days after the so-called dark window, NASA quietly pushed a revised orbital bulletin. The numbers didn't scream, but they didn't comfort anyone either. The new solution confirmed anomalous acceleration. Small, yes, but real, roughly 0.00015 meters per second squared, sustained long enough to push 3I/ATLAS off its predicted track by 900 kilometers in under 48 hours. To most of us, that sounds microscopic. To orbital mechanics teams, that's a red alert. Normally, outgassing models can explain minor deviations. CO2 sublimation, jetting from asymmetric vents. It's all part of the comet playbook. But this shift was clean, uniform, almost deliberate. No corresponding brightness spikes, no photometric noise, no thermal flares, just motion, pure, silent motion. Inside NASA's Jet Propulsion Laboratory, analysts started referring to it as the smooth impulse. That phrase leaked on Slack. Then it hit Reddit. And once Reddit gets a term, it's game over. Mainstream media picks it up before the ink dries. NASA detects smooth impulse from alien comet. Headlines sell panic. But the real story, as always, lives in the margins, buried in footnotes and timestamps. One team at the University of Arizona took a closer look at Hubble's brightness data during the dark period. Their analysis turned up an unsettling pattern. Every 19 minutes, for 180 minutes straight, Hubble recorded faint spikes, too weak for casual detection, but statistically consistent with pulsed emission. In other words, the comet wasn't entirely dark. It was blinking just below the threshold of visual noise. What could cause that? The simplest answer? Rotation and partial venting. But the rhythm didn't match its measured 16-hour rotation period, nor did it align with any known solar cycle fluctuation. The frequency looked artificial, steady to within 1 second across the entire blackout window. When researchers filtered the data, the pattern revealed a repeating envelope, a fade-in, fade-out shape, identical each cycle. Could that be coincidence? Maybe. But even skeptics conceded the cadence felt mechanical. Behind closed doors, two narratives are forming. The conservative camp, led by Dr. Mei-Ling Zhou, believes everything can still be explained by natural physics. She argues that the pause was an illusion caused by geometry, the surge a byproduct of outgassing, and the uniform drift a fluke of solar wind pressure interacting with CO2-rich dust. Her team has modeled the event using advanced plasma coupling simulations, complex but consistent with known laws. Their conclusion, no miracle required. The radical camp, quieter but growing, isn't so sure. They point to the clean symmetry of the acceleration, the rhythmic pulses, the nickel signature, and a faint radio anomaly reported by the Allen Telescope Array, an ultra-narrow spike near 1,420.5 MHz, the hydrogen line, appearing once during the blackout. No modulation, no data stream, just a 2-second ping, too faint to confirm, too precise to ignore. Officially, it's labeled instrumental interference. Unofficially, some scientists are losing sleep. One leaked internal memo summarizes the dilemma perfectly. If we call it noise and it repeats, we're unprepared. If we call it a signal and it's natural, we're fools. Either way, we look wrong. By now, the words rapid intercept are back on every whiteboard. A decade ago, that phrase sounded like science fiction, a contingency plan for the impossible. Now, with 3I/ATLAS rewriting the rules, it's policy. The concept is brutal in simplicity. Launch a compact probe using existing booster tech, Falcon Heavy, Ariane 6, Vulcan, anything that can leave Earth within weeks, and sling it past the Sun for a gravitational assist. Catch 3 I/ATLAS before it exits the inner solar system. No orbit insertion, no landing, just a flyby at 60 kilometers per second, snapping hyperspectral data, magnetic field readings, and thermal maps. Funding requests are already circulating. Insiders say NASA's Planetary Defense Office has quietly reached out to SpaceX and ESA to discuss time-sensitive contingency architecture. The world just found its next space race. Because if this thing truly maneuvered, or if it carries technology we can't replicate, the first nation to reach it wins more than prestige. They win the next century. October looms, and the world's telescopes are holding their breath. As 3 I/ATLAS nears perihelion, the closest point to the Sun, its light curve will explode. If the 3-hour pause was real, that's when it'll repeat. A second blackout, a second speed jump, would remove all doubt. Scientists call it the confirmation window. Every observatory from Chile to Japan is booking time for that moment. Even amateur astronomers are setting alarms. Meanwhile, ESA's Mars orbiter continues to beam back images. Early frames show a fine mist of micron-sized dust trailing behind the nucleus, like smoke from a brake pad that burned too hot. The physics don't line up neatly, but the visuals, they're haunting. Maybe 3 I/ATLAS isn't artificial. Maybe it's just showing us how limited our physics still is. Because the truth is, even without conspiracy, this object defies patterns. Its chemistry, CO2, dominant, nickel-rich, low water ratio, implies a birthplace far beyond what we've modeled. Its orbit traces back through regions of the Milky Way filled with binary stars and collapsed remnants, places where gravity warps space into strange currents, and ejection velocities stretch logic. If this is what natural looks like, nature's toolbox is wilder than anything we've imagined. And if it's not natural, then we just witnessed a test flight across interstellar space, using principles we barely have names for. Either way, our species just got a wake-up call. Something out there, natural or not, moves through the void with control we can't explain. And for the first time, we're close enough to watch. Comment below. Do you believe the pause was a glitch or a maneuver? If it was intentional, what do you think the message is? Observation, caution, or something we're not ready to understand? And if you haven't yet, subscribe, because when the second blackout hits, or doesn't, you'll want to know the truth before anyone else does.